Our next question, sixth question. Question number 6. Given 1 minus 1 by x square into e power x plus 1 by x integral 1 minus x 1 by x square into e power x plus 1 by x dx. This is not easy to integrate by multiplying or separating. So in these type of cases we have some separate formula. If it is in the form, you can directly utilize. Take this power as f of x. F of x is equal to x plus 1 by x. And look at the term here, 1 minus 1 by x square. This is nothing but derivative of this f of x. What is the derivative of f of x? F dash of x is equal to, derivative of x is 1 with respect to x, and derivative of 1 by x is minus 1 by x square with respect to x. So this is in the form of f dash of x e to the power f of x dx, or e power f of x into f dash of x dx. Both are same only. This will be equal to e power f of x plus c. The integral formula is e power f of x plus c. Add this formula also in the formula list. One more new formula introduced here. Integral f dash of x e power f of x dx is equal to e power f of x plus c, or e power f of x into f dash of x dx is equal to e power f of x plus c. In the power we have function f of x, and the f dash of x is multiplied with the exponential function. We can go to the formula e power f of x plus c. Look at here, the power is taken as f of x and its derivative 1 minus 1 by x square. Derivative of x with respect to x is 1 and 1 by x with respect to x is minus 1 by x square. So differentiating the power with respect to x, we have 1 minus 1 by x square that presents here. So this is in the form of f dash of x e power f of x dx, integral f dash of x e power f of x dx. So we can conclude the result here, which is equal to, so 1 is in the form of integral, 1 implies integral f dash of x e power f of x dx, which will be equal to e power f of x plus c. So that is equal to, therefore integral 1 minus 1 by x square into e power x plus 1 by x, that is equal to, into dx is equal to e to the power f of x. F of x means x plus 1 by x plus constant of integration c. So add the new formula in the formula list. Look at the last step here. This is in the form of f dash of x e power f of x dx. So it is equal to e power f of x plus c. Therefore, taking the problem here, 1 minus 1 by x square e power x plus 1 by x dx will be equal to e to the power f of x. F of x is nothing but x plus 1 by x plus c. Therefore, integral 1 minus 1 by x square e power x plus 1 by x dx is equal to e power x plus 1 by x plus c. Question 7. 1 by x into log x whole square. Integral 1 by x log x square, x into log x whole square dx. Now this is not log x square, log x whole square. Log x square and log x whole square not equal. So we cannot bring the power inside. So it is impossible to do that. This type of cases, if we use a substitution method, it will be easy to complete in a limited time period. So I am choosing here substitution method. What is mean substitution method? Here there are two functions appears. One is x, another one is log x. By taking any one of the function as different variable, you can easily complete. Just look at here what I am going to do here. Look at the function into the square, that is log x. What is the derivative of log x? That is 1 by x. Derivative of log x is 1 by x. It is appearing here. 1 by x. This is 1 by log x whole square and 1 by x. So the derivative of this function log x appears here. So I am substituting this function as a different variable. Put t equal to log x. I am taking this log x function as a variable t. Now, I think you understood which is taken as a function. The function which derivative appears in the same function, you take this type of function as t. If I take t equal to log x, its derivative 1 by x appears here. So you are choosing such a function as t. So t equal to log x. What is its derivative? dt by dx equal to derivative with respect to x, differentiation with respect to x. What is the derivative? 1 by x. 1 by x. Multiply here dt equal to or dx is equal to, so dt equal to 1 by x dx. dt will be equal to 1 by x dx. So the entire function are changed into the different variable as t. So the function is converted into 1 implies, the function 1 implies all are converted into, now they are in the variable of x, they are converted in the variable of t here. So substituting here, this 1 by x and dx, 1 by x dx are totally taken as dt, and remaining is 1 by log x whole square. Log x is t, so 1 by t square. Look at here, look at very carefully. This 1 by x dx, 1 by x dx is dt, and then remaining is 1 by log x whole square. That 1 by log x is taken as t, so 1 by t square into dt. So 1 by log x whole square is 1 by t square, and the remaining 1 by x into dx is dt. Now this is easy to integrate now. Integrating, that is equal to 1 by x power n dx. Integral 1 by x power n dx is equal to minus 1 by n minus 1 x power n minus 1 plus c. Apply here minus 1 by n minus 1. The power of n is 2. 2 minus 1 x to the power. Here we have t. T power 2 minus 1 plus c, which is equal to minus 1 by 2 minus 1 into t power 1t, 1t plus c. So we have taken t as log x, substitute here. Therefore integral 1 by x into log x whole square dx will be equal to minus 1 by t means log x plus constant of integration c. It's very easy when we go with the substitution method. And in the forthcoming exercises we will have these type of many substitution methods. Now I introduce here for this problem only in this exercise. For all the others are some particular form, or we can convert into particular forms, but this is not easy to convert into particular form. But if we substitute, if we go with the substitution method, it will be easy to integrate. So for that purpose I have introduced the substitution here. The substitution is applied for the function f of x is taken whose derivative should involve in the same problem. If I take log x as function of t and its derivative 1 by x is appeared here. So choose such a particular function as t. So here log x is taken as t, substitution given log x to t equal to log x. Now differentiate, because we have dx term here. To find the dx or dx term, you should differentiate this. dt by dx is equal to log x 1 by x. Here differentiation takes place, not integration. So you should thorough both differential and integral formulas consecutively. I will list at the end of this lesson or next session. So you should thorough the formulas, then only you can get into easily. So t equal to log x, dt by dx is equal to 1 by x. Now cross multiply, dt equal to 1 by x dx. Now look at the problem. The 1 by x dx are changed as dt here. Dt 1 by x dx will be equal to dt. In the problem 1 by x dx are converted as dt. The remaining is 1 divided by log x whole square. So 1 divided by log x is taken as t, so t square into dt. Now this is in the form of 1 by x power n dx. We have different formula for that, minus 1 by n minus 1 x power n minus 1 plus c. Applying this case, 1 by t square dt equal to minus 1 by n minus 1 t power n minus 1 plus c, minus 1 by t power 2 minus 1 1, so 1 into t power 1 plus c. So substituting t equal to log x here, because the given question in terms of x, so we should give the answer in terms of x. For that purpose, substituting t equal to log x here, so the total answer will be equal to 1 integral 1 by x log x whole square dx is equal to minus 1 by log x plus c. It is very easy when we go with the substitution method. So you should learn this type of integral by using substitution methods. Question number 8, exercise 2.3. This will be the last question in the exercise. This is the last question. F dash of x is equal to e power x given, and f of 0 equal to 2 is given. Then we should find the value of f of x. The function's derivative is given, and one point on the curve is given. We should find the curve f of x. That is easy. We are familiar. We did 3-4 problems in the last 2 exercises. So these type of questions may be asked in 2 or 3 marks. This is very easy. So before entering this, we should know a formula. F of x is equal to integral f dash of x dx plus c, sorry, f dash of x cx. You can take c later. So integral f of x, sorry, f of x is equal to integral f dash of x dx only. Now which is equal to f of x is equal to, substitute f dash of x. F dash of x is e power x dx. This is very easy to integrate. The derivative of e power x is e power x, and the integral of e power x dx is also e power x. So f of x is equal to e power x plus constant of integration c is added. Here when x is equal to 0, f of 0 equal to 2 is given. So when x is equal to 0, put x is equal to 0 in this. F of 0 equal to e to the power 0 plus c. Now f of 0 means that is value 2. So 2 equal to e power 0 means it is 1 plus 0. Anything to the power 0 except 0 is 1. So e power 0 is 1. So 2 equal to 1 plus c. Now c is equal to 2 minus 1. 2 minus 1 is equal to c. So c is equal to 1. Now substituting in equation 1, the integrated function is taken as 1. Substituting in 1 implies f of x is equal to, the required function f of x is equal to e power x plus constant of integration c follows 1 when f of 0 equal to 2. So from that we are substituting the value 1. So f of x is equal to e power x plus 1 is the required function for following these derivative and f of 0 equal to 2 informations. Examples at a glance. Exercise 2.3 examples. The example 2.16, 3 power 2x plus 3 into dx is given, which is equal to 3 power 2x into 3 power 3. So 3 power 3 is taken out. Remaining is 3 power 2x dx, which is equal to a power mx dx. So integral a power mx dx is equal to a power mx by m log a plus c. So using this formula here, 3 power 3 is 27, then a power mx 3 power 2x divided by m log a. M means 2 log a is 3. So this will be the answer for this question. So 27, 3 power 2x by 2 log 3 plus c. And then next moving to 2.17 example. Now separate it. By separating we have e power x by e power x 1 plus 7 by e power x, 7 by e power x dx, which will be equal to integral 1 plus 7 into e power minus x dx, that is equal to integrating now 1 into dx is x plus 7 into e power minus x integral is minus e power minus x. Integral e power minus x dx is equal to e power minus x by minus 1, that is equal to minus e power minus x. So here minus e power minus x, which will be equal to x minus 7 e power minus 7x. So it is equal to x minus 7 e power minus x plus c, that is 2.17. and 2.18 we have now. For 2.18 small common term taken out on the numerator. Listen, 5 plus 5 e power 2x is given, that is equal to, taking 5 as common, 5 into 1 plus e power 2x divided by e power x plus e power minus x into dx, integral dx. And now look at the numerator, take e power x as common, which is equal to integral 5 into e power x. Now here no e power x, so 1 by e power x. Here e power x is removed, we have e power 2x, so 1 e power x removed, remaining is plus e power x divided by e power x plus e power minus x dx. This is very easy. Now look at here, 1 by e power x means e power minus x, and here plus e power x. Look at the denominator, we have e power x plus e power minus x. So both are equal, so we can cancel these two terms. So remaining is integral 5 e power x dx, that is equal to 5 into integral e power x is e power x plus c. This is very simple thing. By taking common 5, 1 plus e power 2x remains. Once again taking e power x common from these two terms. Here no e power x, it is divided by e power x. We have e power 2x, taking 1 e power x, remaining e power x. So 1 by e power x means that e power minus x. So e power minus x plus e power x. In denominator we have same term. So both get cancelled. Remaining is 5 into e power x dx. 5 constant, keep it same. Then e power x integral e power x plus c. That's all. That is example 2.18. And now we have one more example 2.19 here. Further expand with respect to, expand by using a plus b whole square formula. 2.19 integral a square e power x whole square, and then taking this as e power minus x plus e power minus 2ab plus 2 into a into b and plus 1 by e power x whole square into dx. So listen here, a plus b whole square form a square plus 2ab plus b square into dx, which is equal to integral e power x whole square and e power 2x. These two get multiplied. Then plus 2 into e power x get cancelled. Plus 1 by e power x whole square. 1 square 1, e power x whole square is e power 2x. So 1 by e power 2, 1 by e power x whole square will be equal to 1 square 1 by e power x whole square. This e power whole square converted as e power 2x, which will be written as e power minus 2x. So 1 by e power x whole square is nothing but 1 by e power 2x, that is equal to e power minus 2x. So we can write it as e power minus 2x here. So 1 by e power x whole square e power minus 2x dx. Now integrating e power ax means e power ax by a plus constant, for every constant integral according to the integral multiplied, dx appears x multiplied 2x plus e power minus ax means e power minus ax by minus a plus c. So this minus 2 and plus and get while multiply implies e power 2x by 2 plus 2x minus e power minus 2x by 2 plus constant of integration c. This is example 2.19. So we have completed all the examples also today. And then one important thing we should do that is very important. Just list out all the formulas from the exercise number 1. Integral x power n, integral ax plus b whole power n, integral 1 by x, integral 1 by x power n, like that we have a list of formulas. List out all the formulas. Daily write once, twice or thrice. Whenever you get time, just write. You will get practice the formulas. If you know all the formulas, then only you can get into the problem. You can apply whichever, you can choose the formula according to the problem. You can some standard result of integration or specific formulas. If you want to know thorough integration, you should thorough the formulas first. Without knowing formulas, we couldn't integrate any of the problem. So it is very important to know all the formulas of integration first. Then you can learn the integration, how to complete the integral values of a given function. So I am listing once again the formulas here. These are all very important. First of all, you should thorough these formulas. Again, repeatedly I am telling you, you should know the formulas well. Then only you can familiar in integration. Because at the end of every step, we need a formula to complete the integration. Without the formula, we couldn't complete the problem. It may be any problem in integration. At the final step, we should use the following formulas. So it is very necessary. Without the formulas, we can't make it correctly. So get clear these formulas once again. And the first one is integral x power n dx is equal to x power n plus 1 divided by n plus 1 plus c, where n not equal to minus 1. And the second one is ax plus b whole power n dx is equal to ax plus b whole power n plus 1 divided by n plus 1 into a. The constant of the coefficient of x is multiplied with the n plus 1 plus c. And then here 1 by x power n dx, that is equal to minus 1 by n minus 1. The power n is taken here, n minus 1 x to the power n minus 1 plus c, where n is not equal to 1. Here n is not equal to minus 1 for the first two cases, and the third case n is not equal to 1. Suppose n equal to 1, the fraction become infinity. So for that purpose it is invalid. For that purpose we are neglecting n not equal to 1. We are taking n is not equal to 1. And then the fourth case, 1 by x dx, integral 1 by x dx, the power of x will be equal to 1 here. So 1 by x dx equal to log of modulus x plus c, log of modulus x plus c. And then fifth one, 1 by ax plus b dx is equal to 1 by x dx, integral 1 by x dx is log of modulus x plus c. And then fifth one, integral 1 by ax plus b dx is equal to 1 by a, the coefficient of x is taken here, 1 by a, log of modulus of ax plus b plus c. And then for sixth one, integral e power x dx is equal to e power x plus c. That is a very easy formula. In differentiation also, derivative of e power x is e power x. In integral also, integral of e power x is e power x plus c. Then for seventh one, e to the power ax plus b, some constant is added, and two more terms, two of the terms given in the power. E power x means we can simply write e power x. If it is e power ax plus b is given, then its integral value is 1 by a. The coefficient of x is taken 1 by a, e to the power, the function e power ax plus b plus the constant of integration c. And the next one is integral dx. Just that is very easy. Integral dx means x plus c. That is 1 is here. Or integral dx means the derivative of x is dx, and then the integral of dx is x plus c. If a constant appears, 1 into dx means is 1x plus c, and some other constants appears, non-zero constants. So 5 dx means is 5x, 5 by 3 into dx means 5 by 3x, like that. So integral dx is equal to x plus c simply. And then a power x dx, integral a power x dx is equal to a power x divided by log a plus c, a to the power x divided by log a plus c. And then a power mx plus n into dx is equal to a power mx plus n divided by m into log a plus c. The coefficient of x is multiplied with the constant log a if it is a power mx plus n. So integral a power mx plus n into dx is equal to a power mx plus n divided by m into log a plus c. For these two cases, a is not equal to, a is greater than 0 and a is not equal to 1. A is not equal to 1, a is greater than 0. and I told you some of the formulas additionally, that is f dash of x divided by f of x dx. The derivative of the denominator appears in the numerator. We can go with the formula log of modulus of f of x plus c. Log of modulus of f of x is plus c. And on another formula, I have given you integral e power f of x into f dash of x dx. That is will be equal to integral e power f of x. The function in the into the power of e and the derivative is in the product. We can write e power f of x into f dash of x dx or f dash of x into e power f of x in dx. Both are will be equal to e power f of x plus c. For these type of cases, e power f of x plus c. Here we have 7 formulas and also here we have 5. So there are 12 formulas. They are very important. They are very needed to complete the exercise problems. So these things, then only you can learn integration.